Hello students, Namaste. Today we are going to discuss about azeotropic mixtures. Look here, azeotropes means azeotropes derived from Greek language. Azeotrope means A means no, Geo means boiling, tropes means changes. No boiling changes. Azeotropes is also called as constant boiling mixture. Azeotropes is also called as constant boiling mixture. Look here. Now I will write some important points for azeotropic mixture on the board. Look here all of you carefully. Now I will write some important points for azeotropic mixtures. First point here. First point. Azeotropic mixture is binary solution or binary mixture. Binary solution or binary mixture. Binary solution means it containing one solute and one solvent. Here solute and solvent both are taken as liquid phase. Solute means we are taken as A component, solvent means we are taken as B components. Binary solution means it containing one solute, one solvent. Both are exist in liquid phase. Solute we are taken as A component, solvent we are taken as B components. Okay. If more than one solute present in solution, it does not form azeotropic mixtures. And second point is same composition or fixed composition. Fixed composition. Here solute and solvent both are taken as same composition or fixed composition in solution. Here solute and solvent both are taken as fixed composition or same composition in the solution. And third point is boiling at constant temperature. The solution boiling at constant temperature. By adding these three points, you will get definition of the azeotropic mixtures. Now I will write a definition for azeotropic mixture by using above 3 points. Look here. A binary mixture having same composition in liquid and vapor phase and boils at constant temperature. is called azeotropic mixtures. Once again listen, a binary mixture having same composition in liquid and vapor phase boils at constant temperatures is called as azeotropic mixtures. Look here, azeotropic mixture which cannot separation of components by fractional distillation. Azeotropes is a mixture which cannot separation of components by fractional distillation. Due to the mole fraction of A component in liquid phase is equal to mole fraction of A component in vapor phase. Similarly, XB is equal to YB. XB is equal to YB. XB exists in liquid phase, YB exists in vapor phase. Okay. Okay. Now, if XA liquid is not equal to YA in vapor phase, that means here mole fraction of A in liquid phase which is not equal to mole fraction of A in vapor phase. Similarly, XB liquid phase not equal to YB vapor phase, then fractional distillation is not possible for azeotropic mixture. At these conditions, fractional distillation is not possible for azeotropic mixtures. Fractional distillation is not possible for azeotropic mixture. Okay. Generally, azeotropic mixture are basically non-ideal solutions. Azeotropes, look here, azeotropes are basically non-ideal solutions. These azeotropes can be classified into two types. One is minimum boiling point azeotropes, and second one maximum boiling point azeotropes. Look here, the minimum boiling point azeotropes means the boiling point of solution is lesser than either boiling point of pure components like solute and solvent. Such mixture is nothing but minimum boiling point azeotropes. Once again listen here. The boiling point of this solution is lesser than either boiling point of pure components like a solute and solvent. Such mixtures is called as minimum boiling point azeotropes. For example, we are taken here water and ethanol to form minimum boiling point azeotropes. Water and ethanol to form minimum boiling point azeotropes. Now I will take one visual here. In this visual, water and ethanol mixture to form a solutions. Here water boiling point is 373 Kelvin. Ethanol boiling point is 351.4 kelvins. The mixture of water and ethanol, solution boiling point is 351 Kelvin. That means here the boiling point of this solution, which is lesser than either boiling point of pure components like water and ethyl alcohol. Come to here, maximum boiling point azeotropes. Maximum boiling point azeotropes means here the boiling point of solution is greater than either boiling point of pure components like a solute and solvent. For example, H2O and HNO3 to form maximum boiling point azeotropes. Look here, water and HNO3 both are taken into one azeole to make solutions. Water boiling point is 373 Kelvin. HNO3 boiling point is 356 Kelvin. The mixture of H2O, HNO3 solution boiling point is 394 Kelvins. Look here, the boiling point of H2O, HNO3 solution is 394 Kelvin. That means boiling point of solution is greater than either boiling point of pure components like water and HNO3. Such mixtures is nothing but maximum boiling point azeotropes. Come to here. In this case, in minimum boiling point azeotropes shows large positive deviation from Raoult's law. Maximum boiling point azeotropes shows large negative deviation from Raoult's law to form maximum boiling point azeotropes. Once again listen here. Minimum boiling point azeotropes means the boiling point of solution which is lesser than either boiling point of pure components like solute and solvent. Example, water and ethanol to form the minimum boiling point azeotropes. The minimum boiling point azeotropes shows large positive deviation from Raoult's law. Come to here. In maximum boiling point azeotropes means the boiling point of solution is greater than either boiling point of pure components like solute and solvent. Example, water and HNO3. Water and HNO3 to form the maximum boiling point azeotropes. The maximum boiling point azeotropes shows large negative deviation from Raoult's law. Look here, the maximum boiling point azeotropes and minimum boiling point azeotropes can be explained in terms of the graphical methods. Look here. Now graph for minimum boiling point azeotropes. Here example, water and ethanol solution. in ethyl alcohol solutions, ethyl alcohol containing 95%, the remaining 5% containing water. Look here. Now graph drawn in between vapor pressure and mole fraction of the components. Vapor pressure taken on y-axis, mole fraction taken on x-axis. Generally, minimum boiling point azeotropes can show the large positive deviations. Large positive deviations. This is the non-ideal solution graph. It can show large positive deviation. This is a positive deviation graph. Here, mole fraction of water 0, mole fraction of ethyl alcohol is 1. Here, mole fraction of water 1, mole fraction of ethyl alcohol is 0. From here to here, mole fraction increases 5%, means it is. To draw the lines like this, we get here maximum vapor pressure. This is the maximum vapor pressure. So the vapor pressure is maximum, that means boiling point is minimum. Do you know that vapor pressure is directly proportional to 1 by boiling points? We got here maximum vapor pressure from graph. Now graph drawn in between boiling point versus mole fraction. Boiling point taken on y-axis, mole fraction taken on x-axis. The mole fraction of water is 0, mole fraction of water, ethyl alcohols, mole fraction of ethyl alcohols 1, here mole fraction of water 1, mole fraction of ethyl alcohol 0. So this is generally non-ideal solutions. This is a non-ideal solution. These are generally non-ideal solutions. So here we are getting maximum vapor pressure. If the maximum vapor pressure means boiling point is low, like this. So mole fraction from here 0 to 5% increase, that means nearly here. This is the minimum boiling point. This is the minimum boiling point, azeotropic point. This point shows minimum boiling point for this azeotropics. This is the graph for minimum boiling point azeotropes. Okay. Now graph for maximum boiling point azeotropic mixtures. Here we have taken example for the maximum boiling point azeotropes, that is 68% of HNO3 solution. 68% of HNO3 solution means 68% HNO3 and remaining 32% water. Remaining 32% waters. So now graph drawn in between vapor pressure and mole fractions. Vapor pressure taken on y-axis, mole fraction taken on x-axis. Here mole fraction of water 0, mole fraction of water 1, mole fraction of HNO3 1, mole fraction of HNO3 0 here. So here how much percentage is? Only 32% of water should be present in 68% of HNO3 solutions. From here to here, mole fraction of water is increases. So generally maximum boiling point azeotropes can show the negative deviations. This is a negative deviation curve. So this is a mole fraction of water. From here to here, mole fraction of water gradually increases. At this point can show the minimum vapor pressure for this azeotropes. Now we can draw the graph boiling point versus mole fractions. So mole fraction of water 0, mole fraction of water 1, mole fraction of HNO3 1, mole fraction of HNO3 0. Here we got the minimum vapor pressure. The vapor pressure minimum means its boiling point is maximum. Maximum means the curve is upwards. This is the total vapor pressure of the solution. This line indicates maximum boiling point azeotropes. So mole fraction of water from here to here gradually increases. At this point can show the maximum boiling point azeotropes. At this point can show the minimum boiling point azeotrope, because maximum boiling point azeotropes can show the negative deviation, large negative deviation. We draw the curve like this. So this is the graph for the maximum boiling point azeotropes. This is the today our sessions. Okay, thank you.